For example 4, let f of t equal the square root of t times a plus bt, where a and b are some kind of constants. We want to find the derivative of f. Okay, well, notice, of course, that we have a product of two functions here, so it makes sense that I should use the product rule. Okay, so I want to first actually rewrite this thing, because I need this to be in a form that I can use, say, the power rule on, which means, just a second. Okay, that I need an exponent on the thing, which is t to the 1/2 power. All right. Always totally inconvenient when they put t's inside of a problem with plus signs. So, pro tip here is to put a serif on your little t. Just put a little curly down here at the bottom. Yeah, so you can easily distinguish them. Okay, all right, so let's take the derivative using the power rule here, which is the derivative of the first one times the second one. So we'll leapfrog that power down. 1/2 t to the, subtract 1 from the power, negative 1/2 times the second one, a plus b, plus the first one times the derivative of the second one. So remember that these things are constants here, they're just numbers. So the derivative of a, that's 0, it's going to be gone. And the derivative of bt, it's just like a linear term, it's just going to be b. Okay, you can't write with a laser pointer. All right, and you don't want to leave this like this. So first of all, we have a negative exponent on this one, which we don't like. So should I just put it down in the bottom? And the answer to that question is no, you should not. Instead, you're going to do some fancy factoring. And this is going to be the first time we've seen, I think, maybe this fancy factoring technique that we're going to use quite a bit on both the product and the quotient rule. So it goes like this. It goes like this. All right, notice we do have a fraction here, this 1/2 in here. And this t to the negative 1/2 power means that it needs to go down to the bottom. So we're going to have a fraction. And we want one complete fraction. So the easiest way to do this is by factoring out, first of all, the 1/2. I know that there's not a 1/2 here, but I need to factor it out so that I don't have a 1/2 on the top and then I have, a complex fraction. No, we don't want that. So we're going to factor out 1/2. And now, in terms of the variables, they have t to the something in common. What do I pull out? So whenever you factor, the greatest common factor is actually the smallest exponent that they have in common. So I got a 1/2 and I got a negative 1/2. The negative 1/2 is the smallest exponent. There I go again, trying to write with a laser pointer. So that's what I'm going to pull out. And open up some brackets. And then I want to divide all of this by 1/2 t to the negative 1/2. And of course, that's just going to cancel out, leaving me with a plus but, a plus bt. Okay, now here's the complicated part. So understood 1 right in front of this, of course. You have 1 divided by 1/2, right? Because I have this 1/2 that we're dividing it by, which is the same thing as 1 times 2 over 1, which is 2. So I need to put a plus 2 there. But doesn't that make sense? If you were to distribute this 1/2 times this 2, it'd be 1, okay? And then some more little scratch work here. I'm taking t, laser pointer, t to the 1/2 here, and I'm going to divide it by t to the negative 1/2. So divided by t to the negative 1/2. Like bases, you're supposed to subtract the exponents. So 1/2 minus a negative 1/2 makes 2/2, or, just the number 1. Okay, so t to the first power. Wait. Oh my gosh, I forgot the b on that, didn't I? Hey, don't forget that there's this b that's right here. Okay, now don't close brackets with parentheses. That's just bad form. All right, now let's combine some like terms or whatever, and then rewrite this in a very pretty way. So, like this 1, that'll stay on top. That's going to go to the bottom. That's going to go on the bottom. This will all stay on the top. And I have a bt plus 2 bt's, if I switch the order of that, to make 3 of these guys, if I were to combine these things. So on top, I've got a plus 3 bt, or if you prefer. And then on the bottom, I'm going to have 2 and t to the 1/2 power. If you wanna, since this one is in radical form, maybe you should make your answer look like that too. A plus 3bt over 2 square root of t. Whew. There you go. All right, you know what? I don't think that we've spent enough time on this exercise. And the reason why is because product rule, and later when we get the quotient rule, if you can avoid it, you wanna. So is there a way on this particular example to avoid the product rule? And I'm saying to avoid it because, like, look, there's many opportunities to make some sort of errors. It's a little bit more complicated than just term by term taking a derivative. And when we get to the quotient rule, it's going to be even more so. So here is a second version of this exact same problem in another color. This is avoiding the product rule by first just distributing this through here. So f of t, rewriting this, is equal to t to the 1/2 times a, let's put that up front, plus b t to the 1 times t to the 1/2. This is 2 over 2. Understood. Going to add 1/2 to it. That's going to be 3/2. B to the 3/2. And now term by term take its derivative. So leapfrog that 1/2 down. So 1/2 a t to the negative 1/2 power, plus leapfrog this one down, 3/2 b t to the positive 1/2 power. And then you'd have to do your little fancy factoring again. So notice that they do, in fact, have a common factor of 1/2, which I will pull out. And then in terms of the variable here, smallest power is negative 1/2, so it's the one that gets to come out. Negative 1/2. Open up the brackets, and then divide. The 1/2 divided by 1/2 is 1, and then I'll have an a left over, and then the t to the 1/2 will cancel out. So there's the a. Plus, you take 3/2 and you divide out 1/2, you get 3. What? You don't believe me? 3/2 divided by 1/2 is equal to 3/2 times 2 over 1. Yeah, it's totally 3. 3b, and then I think we've already done this division. It's right here. T to the 1/2 divided by t to the negative 1/2 is t to the 2/2, or just, t. Now, isn't this exactly what we had before? Sure it is. The stuff in the bracket's going to stay up top. And then the 2 and the t to the negative 1/2 is going to go down to the bottom. Well, this one, it may have been about the same number of steps or whatever. We ended up at the same exact answer, of course. And I'm not, in any kind of way suggesting that you ever do a problem 2 times and make sure that you got it right. But there are certainly going to be opportunities where if you can avoid doing the product rule by distributing through, then you probably want to. Okay, could we have done that back up here on this example? Could we? No, we can't. There's no way to avoid the product rule on this one. Sometimes you can, and then sometimes you can't. So the next part of the lesson, instead of a product rule, we're going to try to develop a quotient rule.